This is the 5-4 to 5-5 review. Number 2, calculators are not allowed. And on all 3 of these, we are asking for the total distance that the particle travels between time is 2 and time is 4. So what we are needing to remember is that total distance at all, no matter the scenario, the total distance will always be the accumulation of the absolute value of the velocity. So that means that we're going to have to look for when that velocity is positive and when that velocity is negative. And since the time on all 3 of them is from 2 to 4, this is what we're going to be setting up for all of them. Now, because I don't have a calculator, I can't put that into my calculator. So I need to graph each of these to figure out whether it's above the x-axis or below. So on this first one, we have a parabola that opens up and its vertex is at 0, 0. So on that one, it's always positive. So if I accumulate from 2 to 4, the accumulation of the absolute value is going to be the same thing as the accumulation of the regular function. So I will ask, what did I take the derivative of with respect to time that gave me 2t squared? I'd move through the constant, hit the power, add 1, and divide by 1, and then I evaluate from 2 to 4. Plug in the 4 first, plug in the 2 next, subtract them. I have 2 times 64, that's 128, minus 16, I end up with 112 over 3. Next one, if I graph this, it again is a parabola that opens up, only this one has been moved to the right 3 units. Again, it's always positive, so that accumulation from 2 to 4 is going to be the same as the accumulation of the regular function. So I'll probably want to multiply that out so that I can do power rule backwards without having to worry about the chain rule, though you could have done the chain rule as well. We would have a t cubed over 3 minus a 6t squared over 2 plus a 9t evaluated from 2 to 4. So I'll plug in the 4 first, that's a 64 thirds, minus, I'm going to reduce that, so I've got a 3 times a 16 plus a 9 times a 4, and then I'm going to subtract what comes out when I plug in a 2. So I've got 8 thirds minus a 3 times a 4 plus an 18. Put that all together and we end up with 2 thirds. Okay, the last one again is a parabola, but if I factor this so that I can graph it, I know the zeros are going to be 1 and 3. So that means my vertex is going to be at 2. If I plug in 2, I get a 4 minus an 8. That's a negative 4 plus a 3 is a negative 1. So we see in this case that we're getting some accumulation that is underneath, since I want to go from 2 to 4. So again, since I don't have a calculator, I'm going to have to split this accumulation of the absolute value into 2 separate integrals. I will have to do the opposite of the integral from 2 to 3 on this function, because that normal accumulation will be negative and we need it to be positive, so we'll take its opposite, and then we need to add the positive accumulation from 3 to 4 of the same function. So the antiderivative for both of these will be the same. So I'll have the opposite of a t cubed over 3 plus, minus a 4t squared over 2 plus a 3t. That one will be evaluated from 2 to 3. Then I'm going to add t cubed over 3 minus 4t squared over 2 plus 3t evaluated from 3 to 4. So I need to plug in the 3 first, so that would give me a 27 over 3, which is a 9. That can cancel, give me 2 times a 9 is an 18, plus a 9. Then I'm going to subtract what comes out when I plug in the 2. So that's an 8/3. That again reduces to 2 times a 4 gives me an 8, plus a 6. Then I'm going to add the 4 plugged in. And subtract the 3 plugged in. I'm scooting off the page here. Okay, simplify that, put it all together, and we will end up with 2.